All right, so this video is about break-even analysis and market price using linear equations, well, systems of linear equations. So break-even is where we're going to start. And what we're looking for with break-even is you have some cost function right here that the company has to pay to make and manufacture stuff. And then you're going to have some revenue function that they get from selling these items. And eventually, the amount of money that they bring in should pass. And so now they're making a profit. This is our profit area in here. So after a certain number of units of being sold, we end up getting a profit, and this is our revenue cost. And so what we're looking for is that point of break even. So we need two linear equations, one for cost and one for revenue. Revenue is the one below. So let's start with cost. A CD manufacturer has determined that its weekly costs are $1 per CD. That's our slope. It's $1 per CD with a flat rate of 3,000. So that's our B, because that's our y-intercept. So using y equals mx plus b, we end up with a cost function in terms of x, the number of CDs. That is 1x plus 3,000. And anytime we introduce variables, we want to define them. So again, x is our denominator, so that would be the CDs. And our y, which is the cost, and that's in terms of dollars. And so your units are always placed in with the slope. You see it's dollars per CD, and so they just need to match. That's $3,000. Everything's perfect. So now we need a revenue function. We'll do that one in green. So we go back to the problem and see what items are sold for. How much do they bring in? So the CDs are sold for $10 each. That's a slope as well. So our slope here is $10 each. So each CD. See, same thing. So they're selling it for $1. It costs them $1 per CD to make and $10. So they're making a profit of $9 just off the CDs, but we got this initial cost that we have to deal with as well. So all this will go together. So we get 10x, and now we can say R is our revenue, and it's also in dollars. So to break even, that would mean that your cost is equal to your revenue. That's all we look at. So we take our cost function, we set it equal to our revenue function, and we solve for x. So subtract that x, so we get 9x equals 3,000. Divide by 9, divide by 9, and we get 333.33, and then again, x is the number of CDs. So CDs. So it's really about 334 before they start making a profit, but they break even right between the 333 and 34 mark. 333, they're still losing money. 334, they're now making money. So that is our break even x. So a point, by the way, is x comma y, and in this case it's x comma r or c. We don't know. One of the two. They're both the same, right? But it's that point. So now if you plug that back into the revenue or the cost function of 333.33, let's write this nicely. The revenue at 333.3 is the same as the cost at 333.3 because that's where they broke even. So you pick either function, it doesn't matter. And so our cost, or revenue or cost, is $333.33. So the revenue and cost will be the same at that number of CDs. So our point for break even is 333.33 CDs and $3,333.33. See, so if we were to plug that number as well into here, you would see that 1 times this is 333.33 plus 3,000. So same exact number. That's where they break even. And so this is what we're looking for. So that's break-even analysis. So you make two equations, set them equal, and solve. So market price is very similar, but we're looking for equilibrium price and quantity. So on this one, what we're dealing with is a supply and a demand equation. So the way you can think about it is as we sell more units, right, or we increase the price, however you want to look at it, we'll do price down here. As the price goes up, demand for an item will go down. So like if something was, say, $100 and $10, more people will buy it at $10 than they will at 100. I mean, think about it. You go to a shoe store and those shoes are $100. You may buy a pair because you want them. You go back to the store and they're $10. You're going to buy like 15 pair because they're only $10, right? You may think you could even resell them or whatever, but you're going to buy more with a lower price than you will with a higher price. So that would be your demand equation. Now, the supply equation is the other way around. So it's going to go up like this. So as you can sell things for more people are going to want to sell it. So the supply will increase. So if they're only getting $10, people are like, I can't make a profit off that. But at $100, I can make a profit. So as you increase the price, supply goes up, demand goes down. And so what we're looking for is market price. This is our equilibrium right here, where your supply is equal to demand. So the number of units that you are supplying is equal to the number of units that people want. So again, we're going to need two linear equations. So on this one, what they're giving us, and it's usually this way, is you have some price per bushel and you have a quantity. And then there's another price per bushel and a quantity. So we're trying to find 2 points on the graph, one here and one here, one here and one here. And so we take 2 points and we can make a line, take 2 points and we make a line. And we're going to use our calculator for this to make it a lot easier. So at $1.40 per bushel, the daily supply of soybean was this. So that's 1 point, $1.4 per bushel, and we get 1,075 bushels. So we should really mark these as what they are. X is our P, our price. We can even call it P, which is in dollars. And our Y is our supply. We'll call it S. And that one is in bushels. All right, so now what we need is another point. And since I did this picture in red, let's change it. There we go. All right, now our next one, just keep reading. It says when the price falls to $1.20, the daily supply decreases 2. So there's the next one, $1.2, $5.75. Now let's pull out the demand equation at the same time, just so we have it. So at $1.40, the demand was $5.80. So you can see higher price, where we have more supply than we do have a demand. And then so when the price falls to $1.20, more people should be buying it, and they do now. It's $9.80. So you can see that the price went down to $1.20 and the supply went down, but the demand went up, just like we're talking about here. Okay, so here our Y is the demand. So we can call it D, and that's also in bushels. Okay, so now we're going to take these two and plug them in our calculator and do a linear regression on them. So select Stat, and then Edit, and then we're going to clear this out. So if you scroll up to L2 and hit Clear, scroll down, it's gone. Scroll over, scroll up, clear, scroll down. So we're going to put in those two values. So it was $1.40, that was our X, and $1.20. And then now what we're going to do, scroll over, is put in L2 will be our supply and L3 will be our demand. So we're going to go back, pull those numbers and put them in. So our Y1 would be 1,075 and 575. So 1,070 and 575. So 1,075, enter, 575, enter. So this is our supply. So now we have our X and our Y. Scroll over and we'll now put in our demand. So 580 and 980. So 580, 980. And we got to make sure that we put these in correct. So yeah, at 140 we had a big supply and a little demand. At 120 we have a little supply and a big demand, just the way it is. So now we go back to Stat. Let's get out of this for a second. Quit. Hit Stat. And this time we're going to calculate. And we want to do a linear regression number 4. And so L1, L2, perfect. And we're going to store that in our Y1. So hit vars, go to yvars, function, and Y1. Okay. Scroll down, hit calculate. And so there's our equation. So obviously it's going to be 1 because there's only 2 points. So our slope is 2,500 and our b is negative 24.5. So 2,500 and negative 24. So we get y equals 2,500 x minus 24.25, and we stored that in y1. So now the reason I say to store it there now is if you click y, you'll see it's here. You don't have to store it there if you don't want to, but there is our equation. So now we'll do it again. Hit stats. We'll go to calculate. Number 4, linear regression. And then this time we need to change the y-list to the L3. That's where our demand was. So you'll see L3 is on 3. It's in blue. So second 3, and now it's L3. We're going to store this again. So you're going to hit vars. And you're going to go to yvars because we want the y. And then it's a function. And this time we're going to put it in y2. So you can scroll down or you can hit number 2, hit enter. So now it'll take and find it and put it in y2. Hit calculate. And there we go. So again, negative 22,033.80. Okay, so we have this for our equation. And so I'm going to change this to a D. So our demand equation is this. And this will go back to an S so that we can differentiate the two. All right, and there you go. So now we have created a supply equation. So if I plug in any X, and X is our price, right? So I plug in any price I want, and it'll tell me the supply. If I plug in a price here, it'll tell me the demand. So if I were to plug in, say, 10, and remember these numbers are not true. Oops, not true. Not true. The Scooby-Doo version. Not true. Well, these are just made up. But if you plug in, say, 10 into here, right? 10 times 2,500 minus is 75. So at 10, our supply would be 75. And 10 here would be way too much. It would be negative, so it's not going to work. And so what we want now is a picture. And so we've stored them as our y2 and y1. So now if I click y, you'll see they are both sitting there. And we want to get a realistic picture here of how it looks, right? So we need to create a domain for this. And so if you look at it right now, our price goes up to $1.40, our X. And you can see that from $1.40 to $1.20, our supply and demand do cross each other because we went from 580 to 980 and 1,075 to 575. So there is a value in here, a price that would give us a supply and demand that are the same. See how this one went down and this one went up? So we don't need to go above $1.40. So when we set up our domain, we're going to use $1.40 as our max. So if we use a nice logical domain, we go to 0. We can't go below 0. We don't want to have a price that's less than a 0. And our price didn't go up more than $1.40. We know it crossed. So if we put $1.40 for our price and 0 for a price, we can just hit zoom 0. And it will give us a graph that we need, that we're looking for, that nice X that I was talking about. So you see it right there? Because we already know in here, there's $1.40s here. So between $1.20 and $1.40 it crosses. That right there is our equilibrium price. So now we can use those equations to answer everything. So it says if the price is $1.50, find the supply and demand amount. So I've got to actually now increase it past that. So our price here is $1.50. So we go back to our calculator. And we're going to increase this to, I'm going to make it $2 just because I want a little bit of room in there. So then we graph it. So now that's 2 and that's 1. It also gives us a better picture of what's going on. So that's our equilibrium. And it wants to know what are the prices at $1.50. So now if you hit trace 1.5 and hit enter, it tells us the price for our supply. So remember, our supply goes up as price increases. You can also see it's our Y1, our blue, it's our 2,500. So at $1.50, it's $13.25. So our supply at $1.50 is $13.25. And so now we need to find our demand. So we're going to do the exact same thing, but we're going to switch the functions now. So we just scroll. That's it. You scroll up and down, it'll go between the two functions. So for $1.50, our demand, you can see it's going down. So as price goes up, demand goes down, is $3.80 because you don't want to pay a lot, right? So $3.80 is our demand. So 380. And why did I put dollars on there? Because it's not, it's bushels. You see, this is another reason why you want to write out what they are. You can just look up and see what it is. It's bushels. Just put the price on there so I have it where it's supposed to be. All right, so at $1.50, our supply is $13.25 and our demand is $1.50, right? So we don't have enough demand here. We have a massive surplus of items. No one wants them because it's just too expensive. So that's not good. So what are we looking for? We want the equilibrium. So we go back and we find that point of intersection. So to find the equilibrium, we go second calc, intersect, and then enter. That's it, just like before. $1.29, so that's the key price. At $1.29, the supply will be 800, and remember we go back and forth. See, they're both the same. So at $1.29, our supply and demand are exactly the same, 800. So $1.29, we get 800 bushels. So now we can write this. Equilibrium price is $1.29 and quantity is 800 bushels. And there you go. So that is your supply and demand, equilibrium price and quantity, and break-even analysis. It's just sending the two linear equations equal to give you exactly the same thing. Thank you.